Welcome back to CriCri Aviation. My name is Jim Payne, and in this video we're going to go over the aileron and flap control system on the CriCri. Now, if you watched my elevator control video, you may have seen that I have all of this, or I had at the time I created that video, all of the flight controls done because it was difficult to do them completely separate. Kind of had to work through the process at the same time. But we're going to go into detail in this video of exactly how to make all of the aileron and flap control parts. The flap tube itself that's located underneath the seat, the mount for that was already completed way back when we did the fuselage video. So now we're basically taking that flap control tube and attaching all of the aileron and flap control parts to it that connect to the stick. Now the only thing that I left out of this video is the final push rod that connects the aileron bell cranks to the actual flaps, because that is going to be made once the wings are actually completed and installed, and we can actually do some adjustment when we get those flight control tubes in. At that point is when we'll also make the plate that controls the detents for the flap lever. So right now I've got the flap lever installed, but the actual plate where you can actually actuate the flap lever and control the detents. The detents are set actually by measuring the actual angle of the flaps once the wings are installed. So we weren't able to do that at this point either. So there will be one video after this that will kind of do the rigging and the actual flap final settings and final rigging. So what I want to do right now is take the camera and bring it over here. We'll go over some details of the flap system. There were a couple things that I would change if I was doing this different or doing this again, because there were a few difficulties with specifically creating the push rods that connect to the aileron bell cranks to the stick. I think other than that, everything was pretty straightforward and went according to the plans. Getting some of the nuts and bolts in here is very difficult in some of these areas where you just can't get a wrench or get your fingers into to hold things. But anyway, we'll go over that. Let me grab the camera. Let's take a closer look before we get into the video. And again, thank you for watching the video. Please, if you aren't already subscribed to the channel, please subscribe to the channel. Please like the video. And let's take a closer look before we get into the video here. Okay, so as you can see here, I've got the stick installed. I've got the push-pull tubes installed down here on the bottom. And we can actuate the ailerons anyway, and then the flap lever, which is installed back here, which connects to the cross tube, which is underneath the seat through these end caps that are put on there, and we can actuate the flaps by doing this. And there's supposed to be a plate on the side here that controls the detents, where you pull this out, slide it back, it snaps back in, and you can control the three different levels of flaps. But again, I can't create this plate or finish up this flap control lever until we get the wings installed and can actually adjust all of this, because you're supposed to measure on the wings themselves the angle and then come up here and mark on the plate where you need to create the notch for the lever here, so you can get them exactly at the correct angle and degrees that need to be done. So again, this went really well. I mean, everything is just tight. It's really nice. I'm very happy with how it all came out. The one thing that I would probably change, though, is these fittings on the end here. It's very, very difficult to get these pop rivets in. You're supposed to install two pop rivets opposite each other at 90 degrees to one another. You can get the one side in, but then trying to get the pop rivet in the other side, because I couldn't find a pop rivet that was short enough that it wasn't going to hit the other pop rivet before it was already all the way seated. And so you're trying to squeeze the rivet gun and push the pop rivet in at the same time, it's very difficult to do. What I would recommend is that you actually create a solid piece that goes inside the tube, similar to how you do this end here. This end's square and flat. But if you just had a piece of solid 2024 that went and slid inside the tube, you could put solid rivets in here, because you'd prevent the tube from collapsing at that point. And I would just recommend putting solid rivets in both of these and just putting the little insert in there. That to me would be a better way to do this, or at least it's easier. Unless you can find pop rivets that fit, it's very difficult to do. So yeah, I don't know what else to comment about here. I mean, making these parts down here went fairly straightforward. I've got bearings and all of this. There are some very tiny washers and spacers that need to be put between these parts here. And then, just getting the bolts and getting the nuts into underneath here for these plates that go on the end. I don't know if you can see these down in here, but those are bolted in, and it was very difficult to get my fingers underneath there and to get a wrench in there. So it's a little bit tight. But anyway, we'll go over creating all these parts in detail. But again, this all worked very well. And like I said, what we're going to do is I'm leaving out of this video the push rods that go from here down to the actual connection to the flap and ailerons on the wings, which we won't do until we get the wings finished. I did look at buying, I wanted to comment on this, I did look at buying the quick disconnect for these push rod tubes. So there's supposed to be a push rod tube that goes from here down to the wings, but because the wings are removable, you're supposed to be able to have a quick disconnect that will pop off the, basically a ball that's attached to the flaps when you pull the wings off. Now, there's supposed to be a lot of these parts are used on gliders, because apparently gliders have wings that come off, and this is a very common thing to use glider parts for these quick disconnects. Now, the parts that are used for the quick disconnects for the gliders basically are not available anymore. So I tried to look around for a similar product that would replace it. I did find one product specifically made for gliders, but it was like $400 for one of these. And then I talked to the company and they said, well, we won't sell you one unless you buy one of our airplanes. And so that made it even much more expensive. So I tried to look for a suitable replacement. There are parts similar to this that are available on Aircraft Spruce. There's a lot of parts that are available on eBay and Amazon. The only issues I have there is they all seem to be made in China. They seem to be made fairly cheap. These I found, these were made by Dunlop Corporation, and these have a nice knurled edge on the side here for sliding this back and forth and popping off the ball. They seem to be made very well. There's no play at all in it once you get it attached. So I think it's a good solution. That's what I'm planning on using. The only issue I have with these is that there's no real positive locking mechanism. In other words, you can just still slide this, it's spring loaded, and you can slide this off and pop the ball out. And the only thing I was thinking is maybe I could take a piece of wire that I could bend that would attach on either side of this slide mechanism that would snap over the end, just to keep it, have a secondary locking mechanism so that you'd have to pop that off before you could slide this forward. And I might try and do something like that. The other thing I thought is possibly making some kind of a collar that would fit over the top of here that would prevent that from sliding back unless you snap the collar off. So those are the only things I'm thinking about doing with that, but I thought I'd just point these out because these seem to be made really well. And again, they're all steel. So anyway, I thought I'd point that out while we're talking about the aileron system, because like I said, when I make these flight control tubes that attach to the wings, that's what I'm planning on using for now. So let's get into the details of the video. We'll start making some of these parts, and again, thank you for watching, and please subscribe to the channel, and please like the video. Thanks. I want to make some comments on this lower part for the control stick. This is the aluminum part that gets the bearings in it that attaches to the control rods that go to the ailerons. I just made a new one of these. John had sent me one that he had made that was for the metal piece that he had made for the bottom of the stick. I had some issues with the holes aligning properly, and since he had final drilled this to the 1/8 inch rivet size and also drilled the steel part here to the 1/8 inch size, since the rivet holes didn't match up, I decided I was just going to make another one. Now, I made a modification to this one that you might be able to see if you recognize this part, but I added a little bit of material in the center here to the top here. This is supposed to be flat all the way across the top, but I added this little bump out on here. Now, what's supposed to happen on this is this slot that you can see that this part is supposed to fit in between here is curved at the top where the cutout is at the bottom of the stick. And what's really supposed to happen is you're supposed to round the top of this so that it fits nice and snug up in there and actually rests up against the curved part of that cutout. Now, part of that is so that the stick movement back and forth this stick here will actually rest on top of this part and provide some additional support other than just the rivets themselves, you know, taking all the torque back and forth. Now there's not much pressure, so it probably wouldn't have been a big deal either way, but I thought since I had to remake this part, I'd go ahead and put this in here. We'll round the top of this and I'll get this to fit nicely up in here, and then I'll go ahead and drill the holes in it. Now, the other comment I wanted to make too is I noticed this on the first one that I did, is that when I cut this out on the CNC machine, I made these holes here for the bearings about a 1/2 millimeter smaller than the actual size for the bearing. And I noticed that when I bent this on the other one here and here, that it stretches out these holes slightly so that they're no longer round. And when I did the last one, the holes were undersized also, so I was able to ream them out. But I would definitely, if you're going to make one of these on your own, just be careful to undersize these holes, bend it, and then use a reamer to ream out the holes and put the bearings in after it's bent, because like I said, it will make this this hole here not circular anymore. So just comment on that. So what I'm going to do is I'm going to take this, I'm going to go ahead and try and position it in here first. I'll get the holes all drilled in the middle. I'll go ahead and bend it, and then I'll go ahead and ream out the holes, put the bearings in, and we'll Aileron it, put the bearings in, and spot stamp it. And then I'm going to try and get this riveted in right away into the stick, because this is going to be completely done at that point, and then I can have this all ready as an assembly to put in the airplane. So let me go work on this, and I'll show you what it looks like when I get a little bit further here. Well, I just finished riveting the lower control stick bracket in here that has the bearings that go to the push rods for the ailerons. This was a very difficult part to make, and I shouldn't say it's difficult. It was very time consuming with all the different things I had to do to get this to fit and get the parts in here. And I didn't even have to weld this tube together, but flattening the end of this and getting this flat is actually quite difficult, because you can't pound on both sides of it easily at the same time. And so, you know, trying to get these upper rivets so that this is completely flat on the end and sits flat against that aluminum bracket was fairly difficult, but I've got it assembled. It seems to be good now. I also, you know, got that radius up inside there like it's supposed to be inside the tube at the top. So the tube then does provide some support against the bracket, and like I said, it's not just rivets pulling back and forth, which could work loose over time. But again, there's not going to be huge forces on this. The other thing I will mention, I did notice, because when I put these rivets in, of course, it pinched this tube down even a little bit further, because there was some gap that, you know, was taken up by crimping those rivets in, or pounding those rivets in, that now this bushing actually does not fit in the tube anymore, because the tube obviously got bent a little bit, or pressed a little bit, or stretched a little bit. I'm not exactly sure. I mean, it's close. It's just a little bit snug, which it was not before. So what I've got to do is run some sandpaper again through that to just clean it out a little bit. And I might have to take a little bit off that pin just to make sure that there's no binding in there at all. So I drilled out this for the pinhole, alignment pinhole, which is supposed to go through this lower stick attachment. There's a hole right there in the middle of those 3 rivets. That's where that's supposed to go to lock the ailerons. And then I also drilled the bolt hole for the stops. So these little things that stick out the end of this aluminum bracket at the bottom of the stick actually swings in and hits this bolt. So it hits, you can see it hits there, it swings the other way, and it hits there. That's what that bolt is for. Now, one of the things I did create is, you can see I made some washers that were tapered so that the bolt head would be, you know, on a flat surface on either side, because this bolt kind of goes straight through, but it's at an angle where the steel is on this side, and also an angle on this side. So my I went ahead and created some washers that go on there, and then just put a temporary temporary nut on the back side of here. But yeah, that's not necessary. The plans don't show that. My bolt actually ended up being a little bit too short. I'm sorry, a little bit too long. So adding these tapered washers underneath here actually helped so that my bolt would actually fit. And it looks nicer too. So then I can tighten that down and not have to worry about the head and the nut being at an angle with the surface that it's being mounted to. So I did that. I have everything now done on this lower tube for the aileron. So I think what I'm going to do is just take this apart, clean it up, and go ahead and paint it so that I can install it in the aircraft permanently. And then we'll start finishing up the aileron controls by getting the aileron control arm on there, and also all the tubes installed, which we still have to make, that go all the way back to the horizontal stabilizer, aka elevator. So let me go ahead and clean this up and get it painted, and I'll show you what it looks like when it's done. These are all the parts for the aileron trim. I just thought I'd show you them before I assembled it. I'll go ahead and put it together, it'll make more sense, and then we'll install it on the stick. So I assembled this lever first. It's just a number 8 bolt that created an aluminum bushing that's 5 millimeters long that goes in the middle. And then we've got a washer that we just rounded the ends on. This is an aluminum washer that I cut on CNC machine. But this is bolted together, and really this is just a bolt to hold the rubber bands that are used to pull the stick one way or another as you move this lever back and forth. And then this bolts onto the onto basically the top of the elevator tube, where just above where the stick actually attaches. So we'll go ahead and get this bolted onto the airplane, and I'll show you what it looks like when it's installed on the stick. So this is the trim lever installed. I didn't put the nut on here yet. I'm actually going to get a little bit shorter bolt. I think this is a 1/4 inch -6, and I'm going to get a -5 because it sticks out a little bit further than I really want when I get a nut on there and pull everything tight. So so this lever just sits in between two phenolic washers. It's similar to the elevator trim and how it functions. You know, we've got the 2 washers in there that kind of act as a you know, that we can tighten up the nut against, and just kind of allows us to adjust the tension on this arm here, or this lever here. And then what's going to happen is there's rubber bands that connect from this hoop that we created here, and it's going to connect up to somewhere here on the stick where we're going to drill a hole. And so when those rubber bands are connected up here, we can adjust this back and forth, and it'll pull the stick one way or another for our aileron trim. So that's installed at this point. You can see I've got the whole stick assembly now installed, and now we can start working on the bell cranks and the flaperon connections, which we're going to work on next, and connect up the tubes that need to connect between the bearings here at the bottom of the stick and the aileron bell crank. So that's what I'm going to start working on next. I'm starting to work now on the ailerons and the flap system on the CriCri. So John was able to make these for me on his CNC lathe, and these are the end caps that go on the tube that runs underneath the seat pan that connects the flap system to the aileron system. And so what I wanted to do at this point was to try and get these riveted on the end of those tubes, and then also get these brackets made, which actually mount on here like so. But the end of this has to be bent 90 degrees, and then there's a bearing that goes in here, and this is basically what the aileron bell crank attaches to. And I want to get these parts done so that I can install these on the airplane and actually get these bolted in. And then this is the flap lever that we're going to install also, that gets bolted through these same holes in conjunction with this. And on one end it gets bolted on the inside of here, and bolts go through this bracket all the way through this aileron level, I'm sorry, the flaperon lever. And so I'm going to try and bend this. Now this was not shown in the drawings to the unbent dimensions. I mean, it had basic dimensions from, let's say, the bend line down, but here at the top was kind of left for you to try and figure out. And of course, if I was just bending these by hand, well, I'm bending them by hand, but if I was cutting these out by hand and bending them by hand, I would probably just do a square piece of material that was flat. I'd put a bend in it, and then I'd go back and shape the bottom of it and shape the top of it to match wherever the bend ended up. Now I'm trying to use a CNC machine to cut these parts out and hopefully bend them accurately, and of course I was hoping to get the right dimensions top to bottom so that I don't have to trim a whole lot afterwards. So this is going to be a real test here. You can see I didn't even drill out the bearing hole here all the way. I just tried to mark it basically with the same size hole that I used for the mount holes. So what I'm going to do is try and bend this and see where this hole ends up after I bend it. And if it's where it needs to be, then I'll make another one of these just like this. If it's not, I'll probably go back and modify the drawing a little bit and see if I can cut it either a little longer or a little shorter, depending on how it comes out. So let me try and bend this. This needs a very large radius in here. This is a 6 millimeter diameter. I'm sorry, 6 millimeter radius. So it's almost a 1/2 inch pipe that I'm going to have to put on here to try and bend this over in the vise. I have no idea how this is going to go, but I'll give it a try. I'll show you what it looks like when I'm done. Well, this is how the first bend went. It actually went quite well. I did not anneal this because we're using such a large radius here. I was able to just put it in the vise and clamp a 1/2 inch rod up against it and pound it over, and it wasn't too bad. Now, the end dimensions are that I am 1 millimeter shorter here than what the plans say this should be, and I'm 1 millimeter longer here. So I had my bend off by about 1 millimeter. I don't think I'm going to worry about that too much. I'm going to go ahead and cut another one of these and try and bend it. I think it's more important that these are bent the same than maybe being exactly the measurements. So I'll try and bend another one. I'll see where that one turns up at. But the first one went okay, and like I said, this only affects the flaps. It doesn't really affect the ailerons, so that it's the flaperons that move backwards using this with that tube, and yeah. Again, I think just the 1 millimeter off is probably as good as I could hope for bending this from scratch like this, but or from a complete cutout versus just a stock piece that I was bending and then trimming afterwards. So let me try and do another one. We'll see how that one comes out and see if we're close to this one or close to the correct measurements on the plans. Well, success. I did cut out a third one and bent that one. What I didn't like is that the first one I did was about 1 millimeter undersized, but the next one that I bent was about 2 to 3/10 of a millimeter oversized. So the difference between these two was quite a bit. So I went ahead and just cut out a third one. I bent that one, and it came out perfect. It's identical to this one. So it's about 0.2 to 0.3 millimeters longer in this direction than the plans say, and 2 to 3/10 shorter on this side. So I'm not really concerned about it because at least they match. And the other thing I did have an issue with is that in both cases when I bent these, this part was a little bit crooked, and so it must have been how I was swinging the hammer because they were both crooked the same direction. So I did put the ends of these back down into a vise, and I was able to hit the side of it here and actually just bend them back to be perfectly vertical, which is what I was hoping to get out of these. And if you use one hand and try and put these back to back, the fact is they're exactly the same height, and the holes line up, which is exactly what I wanted. So I'm going to go with that. I'm going to have to spend some time now drilling out the bearing holes in these because I did not pre-drill them. And I'm not sure I would have either, because when I put these into my vise, I put them in this way and I bent this end over. If there had been a big hole in here, I would have messed it all up. So the more material you have to pound against, the better off you are. And I think it was easier for me to grab this end and put the radius underneath here and then just bend this tab over. So I'm not sure I would have done it any other way except this way, and now I'll go back and see if I can widen out these bearing holes and see if we can get these ready to attach to the ends of our flaperon tube. So all right, let me clean these up. Well, these turned out really, really well. I'm actually very happy with how these ended up. I got the bearings stamped in there, and I've got these all drilled to match the brackets that are supposed to attach to on the side of the flap tube. So what we're going to do is we're going to go back in the airplane now, and we're going to try and get everything related to that flap tube installed. I still have temporary hardware on the flap tube, and I also have the circular end caps that these attach to that need to be pop riveted onto that tube. But I've got to finalize everything, because once those are pop riveted on the end of that tube, they can't come off, and that tube can't come out. I mean, the brackets can, but let's go look at the airplane and I'll show you what I'm talking about. So this is a flap tube that I've been talking about. So when you rotate the flap handle, this rotates this tube from side to side. It spins these things that are on the end that we bolt the those bearing brackets that we were just looking at that attach to the aileron. So these are supposed to be pop riveted onto the end of this tube. They're supposed to be snug up against these phenolic blocks on either side, so there's no play, and then this tube rotates. when you move the flap handle. So what I have to do right now is there is still temporary hardware holding these phenolic blocks onto the backside of frame 4. So I'm going to go ahead and unscrew all this and get the correct hardware on here. And then we're going to start drilling out the holes and pop rivet these on the end of the tube. Now the only thing that's critical about these is they have to be parallel. So these holes have to be at the exact same angle on both sides, rotationally around the tube, so that when we attach those brackets that hold the aileron bell cranks, that they line up on either side. So that's the only thing that's critical here. And again, make sure there's no play. You basically want to push these up against here, drill the holes, and pop rivet it in the airplane, which is what I'm going to do. So let me change out the hardware, and I'll start pop riveting these on the end of the flap tube. Okay, I got the hardware installed now for these phenolic bushing blocks for this flap tube. I've decided that I'm not going to pop rivet these on the ends quite yet, because I think what I'm going to do is when I drill these out, I want to Aileron this first, and what I'm going to do is drill these out and pop rivet it as I go. But I want to be able to slide this tube over out of the way, because down in the very bottom there, we're supposed to install this. And this sits over the very bottom of frame 4 there, and there's a couple little standoffs that I've already made that get this thing elevated a little bit off the floor down there. But then this needs to be installed, and then there's a steel rod that needs to go from this up to the bracket that attaches to this. And so I want to get this installed down in the bottom there of frame 4 before I go ahead and get this installed on the side. And I can't install the bracket that goes on here anyway that we already made earlier with the bearing in it until I get these in and get the tube made that needs to go in here that attaches to the aileron bell crank. So there's a lot of little pieces here I have to work on, and I'm just going to keep going here and just see if I can get these in right now. I gotta Aileron these and spot stamp this bearing in and install that at the bottom. I'll show you what that looks like when that gets done, and then we'll go back to finishing up the parts that attach to the flap tube. I thought I'd just show you what these parts look like all together. So there's 2 of these, one for each side, that get a bearing installed in it, and then there's thinner spacers here that go on top of the base of frame 4, and then there's 2 thick spacers that go from the skin of the lower fuselage to where this sticks out, kind of like this. So this end sits on top of the base of frame 4, this sits just out on the skin, and then we got to put 4 number 6 I think bolts through all of these. So I'm going to just try and get this done right now real quick. I'll get this stuff Aileron, spot stamped, and get the bolts drilled, bolt holes drilled in the lower fuselage. We'll get these installed. Well, hopefully you can see that little bearing down there that's installed in that little triangle piece there behind frame 4. So I finished installing those on both sides, and they're sitting on top of the little spacers that I had. And the reason for the spacers is just to make sure that that part sits flat, because half of it's sitting on that angle on top of the backside of frame 4, and the tip of that is just sitting on top of the skin. Now I had the holes already marked in frame 4 and the lower skin from the previous step when we were actually building frame 4 and the forward fuselage. So I went ahead and just drilled those out. I clecoed that little triangle piece on the bottom of the airplane, and then just drilled out that 3rd hole that was never marked, and was able to install those pretty quickly. So so now that those are installed, we don't have to get down in that area. Everything's pretty easily accessible as far as putting whatever rod is that we need to run down there for the aileron controls. So I think what I'm going to do now is go ahead and start finishing up the flaperon tube here, or this flap tube that's on the back, and just get these end parts riveted onto the end, and that's really the next step. And then once that's done, we can start working on the actual aileron controls. So I'm going to go work on that next, and I'll show you what it looks like when I get the ends onto that tube. So I was able to get further here on the flap tube. I was able to get the ends here pop riveted onto the tube. Now I did have some issues with this. When I made these phenolic bearing blocks here, I made them so that they fit this tube exactly. Now there's supposed to be a clamping feature here. I think you can see it over here where it's cutout on the bottom, you're supposed to be able to screw the screw in and tighten it on the tube. Now, I made these bearing blocks though so that it just fit perfectly on the tube. There was a tiny bit of friction, but they fit really nicely. But I ran into a problem as soon as I pop riveted these end caps on the end of the tube, because those end caps were not tight on the tube. They weren't loose, but they weren't like, you know, it wasn't a press fit, tight fit. So what happened is when I pop riveted the tube, which is fairly thin, this is only like 35 thousandths thick aluminum tube, when I pop riveted on there, it expanded the end of that tube just a tiny bit. I mean, you know, thousandths of an inch. But then what happened is as soon as I did that, it tightened up inside this bearing block to the point where when I tried to move it, there was a little bit too much friction, even with no pressure in on these screws. So what I had to do is I actually had to take this whole tube assembly out. I had to take these bearing blocks out. I had to drill out one of these end caps that are on there, and I had to just use I actually took a drum sander sanding tube, and I just cut it in half. I rolled it up, and then I put it inside of each one of these bearing blocks once I pulled them out, and just moved them around in there just to sand a little bit off of the inside of those phenolic blocks. That seemed to work perfectly. I was able to get a nice, very round hole. And then I put the whole thing back together, and then now I'm able to adjust the friction here by just turning the screw a tiny bit, but you know, even without the screws turned, it has seemingly just the right amount of friction. So that was me trying to be too particular when I created the bearing blocks and just didn't want them loose, and you know, just really concerned about that. But I was obviously concerned about too much, I guess, creating my own problems by trying to be a perfectionist. So what I started working on next is the rod that needs to go down here in the bottom that goes from that lower bearing to this upper bearing. And I've actually made one here. This is what it looks like. So this has to go basically where this rod is. I'm actually using this rod to measure from the bottom of the fuselage up through the first bearing, up through the second bearing, and then I'm putting a piece of tape there, and then figuring out, you know, when I move the flap lever, where, you know, what happens to the tape line here. Does it go up or down? Because we need to actually adjust this so that at its lowest distance or its lowest point that it's resting against the fuselage, which is actually when the flaps are extended. And then when we retract the flaps, this lifts up just a little bit and comes off the bottom of the fuselage. So I need to adjust the length of this tube here so that it's perfectly the correct distance from the bottom of this bearing, which is supposed to be right at this surface here, down to the end of it, which is supposed to rest on the fuselage when the flaps are extended and sit slightly off the fuselage when they are retracted. So that's what I'm trying to work on now. Now, I made this out of a solid piece of 4130. I actually just started out with a rod like this, and I went on my lathe and I made this. Now, this is supposed to be made in two pieces. You're supposed to be basically make the end of this in one piece, and then you're supposed to have a hole in the bottom of it, and then you're supposed to get a 6mm tube and insert it into this and then weld it around the bottom here. I didn't want to do that. I had the stock here. It was easy enough to do on my lathe. And the other issue I had is that I can't buy 6mm tube, and this has to be 6mm to fit inside of the bearings. So I would have had to have either cut down a 1/4 inch down to 6mm, or I could have probably just cut down the end of it here. But then I would have had to have gone with thicker tubing instead of the 35 thousandths or 1mm, because it would possibly get a little bit too thin down here. So anyway, I just decided to do this on the lathe. It worked really well. It turned out really good. So I'm going to make another one just like this. It prevented me from having to weld anything, which I'd prefer to do that anyway. So I'm going to try and fit this in here, see if I can get this underneath here. And then what bolts on top of here, this is where the aileron bell crank attaches to, right on top of this bearing. It screws down on top of here, on top of this bearing that's in here, and then this just rests on the bottom, and this just pivots back and forth, similar to what this tube here is doing. And it just keeps the aileron bell crank aligned properly when the flaps are extended. So it's part of the flaperon configuration. So that's what I'm going to finish working on. I'm trying to get to the point where I can actually attach these aileron bell cranks here, and then I will be, for the most part, done with the flaps and aileron connections, and I can just work on the flight control tubes that connect these together. So this morning I started off by cutting these aileron bell cranks out on my CNC machine, cleaned them all up, installed the bearings, alidined them, spot stamped them. So these are ready to go and ready to be installed. And these get bolted on top of those steel pins that we were working on with the flap system earlier. Now I do want to talk about that those pins a little bit more. So let's go look at that in an airplane, because I'm having some issues actually figuring out how long to cut them. So this is the pin that I was talking about that we were installing earlier. Now we're supposed to adjust the length of this pin so that with the flaps fully extended, that this pin is just resting on the bottom of the fuselage. And if I rotate this tube, vertical, there's a fair amount of play in there, at least 1/8 of an inch. And then as you rotate this back, the play gets a little bit less and a little bit less until you get to a point where it does touch, which is right about there. It's just grazing the bottom. I can feel it. There really is a tiny, tiny bit of play. Now, the issue I'm having here is that this is supposed to be adjusted so that the bottom hits at 27 degrees of flaps, or flaps fully extended. Now the question is where is this tube rotationally at the flaps full extension? And the question is, I really don't know. Should I assume that this rotation of this and the tube is actually 27 degrees? I don't think I can assume that, because the distance this is traveling with the turning of this tube has to go through a control linkage that goes through to the flaperons, and then there's a pivot point there with a rotation, so there's no guarantee that that would be the same. So how do I know what length to cut this to now, unless I do it after I've already installed the flaps, have the control rods here, have the flap handle here and everything completed? Do I go back then and trim this off to the right length? And I don't think I'm going to do that. Getting in here to these nuts and bolts that attach around the end of this tube is very, very difficult. Taking this tube assembly out is very difficult. It's almost impossible to get to that nut and or bolt on the back side of there. So I really don't want to take this apart again, and so I really don't know exactly what I'm supposed to do here. I did put an angle gauge on here between here and frame 4 and determined that this pin is basically hitting just slightly past what would be 27 degrees of angle on the top of this bearing assembly. I have to assume at this point that that's close. The other thing I did is I attached the handle, and according to the drawing, the handle should come up, and the center of the top, very, very top of the handle, should be centered right on the edge of frame 4. I did that and verified that's basically the same angle. And again, that's just looking at a picture in the drawing. I don't know if that's accurate or any kind of accurate measurement. So I think what I'm going to do is I have these trimmed right now at 104 millimeters from the bottom side of this bearing, which is the the flange on the bottom of this pin, all the way down to the very bottom of the pin is 104 millimeters. The plans say it should be 103, but says to adjust it to your airplane. So I think what I'm going to do is I'm going to leave it at 104, because it isn't hitting before I get to 27 degrees on here. And I think my worst case scenario is that once I get the flaps and actually measure 27 degrees on the flaps, then come back in here and make sure that this pin isn't rubbing on the bottom, that's the only real thing I can do. And you can feel it. If you turn this a little bit too far and you put your hand underneath the bottom of the fuselage, you can feel the skin just being pushed out when it hits, because the skin is only 20 thousandths down here. It's very thin. So I guess that's what I'm going to do. I'm just going to have to, worry about it later. Because the other thing I tried to do is I actually started to make the flap handle attachment here, or adjustment here, that gets bolted to frame 4. I started making that, but then the plans say, well, don't cut the notches in for the flap indents until you've verified the actual flap extension measurements on the flaps themselves. So again, I couldn't install the handle here and even get any of this installed until the flaps are actually, and the wings are actually on the airplane, which I'm not at a point where I don't even have the wings made yet. So yeah, I just wanted to point that out. What I'm going to go ahead and do is leave these the length they are, which I said was 104 millimeters. I'm just going to pull these out. I'm going to paint them real quick, just so the outside of them doesn't rust, and I'll tape off the bottom where it goes in the bearing. And then I can permanently attach these parts to the flap tube with the actual hardware I'm going to use, probably except for the top here where it has to bolt to the handle that I haven't installed yet. But I want to get the aileron bell cranks installed on here so I can finish up the flight control tubes that go from the stick over here back over to those bell cranks. So I'm still working on this. It's a little bit confusing on how this is all supposed to come together, but I want to get to the point where the stick is installed and attached to these aileron bell cranks, and then we can worry about the actual flight control tube that goes from the other side of that aileron bell crank to the actual flaperons. I'm not concerned about that until after we get the wings done, but I wanted to get all of this flight control stuff completed before I moved on to finishing the front part of the fuselage here and actually working on engine installation completion and instrument panel and things like that. So let me keep working on this. I'll see if I can get these pins installed with the aileron bell cranks bolted on top, and I'll come back and show you when I get a little bit further here. I forgot to mention one other thing. I made these yesterday on the lathe, and what these are is these are tiny little 1.5 millimeter thick washers that have a 45-degree taper around the edge. And these actually install underneath these aileron bell cranks like this. Actually, I think it goes upside down. It goes this way, like this. And what that does is it raises this aileron bell crank just a little bit higher than the top of that bearing that attaches to the flap tube, so that as this pivots and rotates, that this bearing or this aileron bell crank doesn't actually start to rub on those other bearing assemblies that are attached to the flight control tube, because the pivot point of that shaft that these are attached to is an odd angle, and it rotates at a much larger circle than the actual bearing assemblies that are attached to the end of those that flap tube. So again, I just want to show you that I made these tiny little washers, and I did test them out to see how they actually worked. And you just put them on top of the end of that pin, on top of the bearing, and then you set this on top. And you can see as you rotate it that this gets closer and closer and closer to rubbing and hitting. And again, that's another indication to me that the flap tube isn't going to be rotated any further than I have it now, because it's almost at the point, even with this little washer on top of there, that the outside of this underside of this flap bell crank is almost about ready to hit that top bearing assembly that's on the flap tube. So I wanted to comment on that because this is going to get installed underneath here, and you won't be able to see it once I get it in. But yeah, let me go work on these a little bit more, and I'll show you what it looks like when I get further here. So while I was waiting for the paint to dry on these steel aileron bell crank supports, I went ahead and tried to get everything ready here to assemble the push rods that connect from the control stick to these aileron bell cranks here. Now, there's lots of parts involved here, lots of small little things to make here. So I made these on the lathe and the mill. So these are one end of the bell crank, one end of the push rod. I believe this is the end that connects to the aileron bell crank. The other end we have to make similar to how we made the ends of the control tubes for the elevator, and we have basically these parts here, which I cut on the CNC machine this morning and bent in a vise. You have to put a joggle in these, but these are 63 thousandths, so it's a fairly significant joggle. What I ended up doing is putting a piece of tape on here and marking the correct distance from the center of the attach bolt hole over, which I think was 12 millimeters, and then I did another mark 6 millimeters from there, and then just put it in the vise and bent it over one direction, flipped it over, and then bent it over the other direction. Now, to bend it back, what I ended up doing is I had a steel tube. This is aluminum, but I had a steel tube of 3/8 size, and I put it up against the part and actually just pounded on the steel tube to bend it back up. Then that worked perfect. If you don't use something like that, it's difficult to get the part to bend without unbending or ruining the first bend that you did. And by using that pipe, that worked out perfect. I'd recommend doing that again because it was much easier just doing it in the vise, and it was quick. So I've got all these parts then cut out, drilled, Aileron, ready to go. This is the piece that is going to go inside of the tube once we flatten it to install these parts, and this is what will rivet through this part to rivet these together through the tube. Now, I did have to create these crazy little washers here. I don't even know if you can see them in the camera here, but these are 2 millimeters thick, a step washer that has a 0.5 millimeter flange on the big side, and then on the small side it's a 1.5 millimeter thick flange. And what these do is they go, basically this goes, let's see, this is the bottom side of it. So these go on the inside of these parts here. And I believe what it's to do is when we attach this to the bearing that's in the control stick, this washer is required to give us a little bit more distance that we can, or a little bit more travel that we can have on the bearing before it hits something in here. So we actually are supposed to glue these in here, and I think what I'm going to do, the only reason to glue them in, I believe, is just to hold them in place when you're taking on and off the this control rod. So what I think I'm going to do is just use some super glue or something, just something to, again, get it held into place so that when I put it on the bearings there, they don't fall off. So I'm going to work on assembling these tubes next, because once these tubes are done, the paint will be dry on the those rods that I showed you earlier, these that we're going to install on, as part of the Flaperon setup that we can then bolt these on top of. But now I can get all of this done, all of it bolted together, and once it's all bolted together, this is all I wanted to complete right now for the Flaperons. There's one more control tube that goes from the other side of this bell crank to the attachment to the wings, but I'm not going to do that until I actually get the wings installed, and then we'll make those just to do the final attachment, and that's where the adjustment is on the Flaperon. So once I get all of this done, this is all the fixed part of the Flaperon system, and then really 90% of the control rods and Flaperon system is complete. So let me go ahead and assemble these tubes, assemble these parts on the tubes here and get these cut and get these finished, and then we'll go ahead and assemble this all in the airplane. Well, I realized after I just made the last video that I only have 4 of these washers, these little step washers, and I gotta make 4 more because I need 8 of them to go in all the pieces here. So I'm gonna go make 4 more of these. These are kind of a pain to make. If you get them right, cutting them off the lathe, they're pretty good. But if you get them a little bit too, obviously you get them a little too thin, you gotta toss it. But if you get a little too thick, then you got a little bit of filing and sanding to do, which is a real pain, and I tend to drop these things on the floor and have a hard time finding them. So let me go make 4 more of these so I can get these control rods finished. I was able to finish these little push rods yesterday at the end of the day, and I think by the end of the day I realized that it actually took me almost all day to make these, between making all the little parts and the little step washers and everything, and then riveting this together. I had a lot of issues. Issues getting these washers glued in here with super glue was a pain, because you can't just glue them in there and get them close. You have to align them somehow with the holes exactly. So I ended up using the end of my 5 millimeter reamer and sticking this in there. And then from the other side, I put glue on the little washer, and then from the other side, I would set it on something and pop it up in there and push it in there. But then you got to try and get this out of there before it gets glued to the super glue, before it glues to the end of the part. So between that and doing other operations on here, such as riveting and stuff, and having them pop off, it was just a pain. The other issue I had was with these rivets on the end here. Obviously, we had issues just getting the pop rivets in the tube for the elevator, the pop rivets, because they don't fit. They're too long when you insert them. So you can insert 2 of them, one here and one this direction, and then you can go from the other side and actually pound the back side of it flat. But there's a steel ball in there, so you can only pound it so far. And then when you try and stick the next rivet in, it doesn't go all the way in. So you got to try and squeeze the rivet and push it in at the same time. But in this case, they're even too long to be able to do that, and you actually get it so that when you pop this one, it sits higher than flush with the surface, which obviously isn't good. Now you can tap this side with a hammer to tap it down in there, which will flatten it a little bit on this side also, and you can get it to work. I also stuck it in the vise, this direction, and clamped them together to try and push them together to get them all the way in there. But they don't look good then, because you flatten the rivet kind of funny looking, which I don't like. So a lot of things I didn't like about this. What I would do on the end here is I would do this differently if I were doing this again. Obviously the tube in here is hollow,
but what I would do is actually on my mill an insert that would go inside of the end of the tubes, similar to what we did here to create a hard point inside of the tube. And I would do an insert in there. I would drill it out through, with the 2 holes, and I would just run a solid rivet all the way through here and just use the rivet squeezer just to squeeze those rivets and be done with it. It would be so much easier than hassling with this. I drilled this out more than once. And the other issue is you almost can't drill it out because the ends of the rivets are touching each other. The steel ball ends are. So if you start to drill it out, you have to drill it all the way through the 2 pieces in order to get it to break loose so that it'll actually come out, because it hits the tail of the other end of the rivet that's on the other side. And then the other issue too is you can't get the rivet tails out if you just want to replace the back rivets and not the front rivets, because there's no way for the pieces to get out, the rivet tails to get out, because they're being blocked by the other rivets. So again, this was all a very painful process, but I did get it done. I thought these were going to be quick and easy and fun to do, but it was not very much fun. The other thing too is I ended up with a silly problem that I did myself. So on the end here, you can see I kind of was looking at this before. I'm like, why isn't this hole lined up with the radius, even radius on the end? You can see my hole looks like it's too far in, and these are actually too long. Well, I found out in the plans what they've done is that all the measurements are taken from an imaginary end of a ball that's sitting out here back to the hole. And so I didn't realize that. I drilled the 9 millimeters from an imaginary endpoint back, which I did it correctly. The only issue is that I was supposed to take off like 3 millimeters of actual material off the end of this and round it to get 6 millimeters away from the hole center on the end, because I guess they're assuming that, I guess if you have a lathe that can create some kind of ball end when you do this, you could radius this end and this end at the same time. Now in my case, I just did a cylinder with a flat end on it on the lathe, and I took it over to the mill. I cut the slot, and then when I got all done with it, I just went over to my disc sander, and actually a combination of a file and a sander, and I just rounded the surface of the end so that the bevel around there matched the bevel that goes along the side. And that worked, but what ended up happening then is these ends of these parts are actually about 3 millimeters too long. I should just go back to my disc sander and sand the ends of them off and then re-round them again, which I can do. I've got issues because I've Aileroned these already, so they're not going to look good if I do it. But that's what I should be doing to fix these. But just be careful, if you're making these by hand, you're not likely going to be able to create a complete ball end when you do this, like I did, and you might have the same issue. But it's easily fixed, and it's not going to be a problem unless I could even leave these like this. I could bolt these to these Aileron bell cranks. The question is at full travel, are these tips hitting anything? Are they hitting like the inside of here, on these parts? So I would have to check and make sure if I was going to leave it, if there's going to be any interference. There probably isn't, but again, that's what I'm going to have to do to go fix these. So I'm done with these now. I can finally get everything installed in the airplane, which is what I'm going to try and do next. I'll go ahead and bolt these in right now and just see what they look like and if they're going to hit or not. If they do, I'll go ahead and just round the edges like I should have in the beginning. So let me get these installed and get everything put together for the Aileron controls, and then we'll take a look at it when it's done.
So I was able to get all of the Aileron system basically reinstalled. So all the push rods are installed to the control stick. I've got the Aileron bell cranks installed, and those rods that are underneath there that we installed in there. So I installed all of this permanently. So I've got actually all of the final hardware installed in here. I greased all of the bearings when I installed it. So everything is kind of set up right now to be, final installation as far as this goes. What we'll do is we do have to make the push rods that go from the Aileron bell crank down to where that connects to the ailerons where the wings are installed. And I'll have to come back and make those later, and then that's where we'll do all the adjustments for the stick and the flaperons connected to the ailerons. I also did bend the flaperon handle, the flaps handle here. It's not finalized because I can't actually finish bending it until I make the indentation, for the different flap settings that need to be installed here, which can't be made until we actually get the flaps and the wings on the airplane and do all the adjustments in the end. So this will be something I'll finish in the very end, but I did get it installed so that I can at least move it back and forth, and you can see how this works as far as the flaps go. And then you can see the ailerons. I can hit the stops on either side. There's no play in the middle at all. It works very, very well. So I also finished the trim lever here. So I had the trim lever finished before. I was waiting on a bolt that was shorter here. I installed the shorter bolt. I installed the bolt that goes through here and the washer that creates the little standoff for supporting the rubber bands that are there for the trim lever, which you can see if you pull to one side or another, it just pulls the stick that direction. So it gives you a little bit of trim ability to have adjustment there. So now I'm not thinking that rubber bands are the final thing I will keep on here. In fact, I was actually thinking maybe hair ties would be a better option for something that's a little bit more durable than just rubber bands. But I'll have to play with that down the road and figure out what I'm going to do. So the flaperon and aileron system is basically complete up to the push rods that we need to make for the wings. I did want to comment though, I installed all of this permanently. So I've got the actual final bolts, nuts installed on here. I greased all the bearings when I installed it. And I did want to spend some time commenting on the bolts that I ended up using, because that becomes quite an issue, especially when we're dealing with metric hardware that has to go through the bearings. What I ended up using is these bolts here. Now I got these from McMaster-Carr, and I had a really hard time trying to find hardware, metric hardware that is partially threaded, so metric hardware that has a shank. And of course the plans recommend that you get the correct length shanked bolt to be able to install through here, so that you have a shank that goes all the way through the part that you're screwing together or bolting together, and then coming out the other side is the shank, and then you just put a nut and a washer on there to finish it off. Now there's very few bolts that you can find that have partial threads. In fact, most places, 90% of people, there are places I could buy from, only had socket head cap screws that you could get in partial length. I really kind of wanted a button head cap screw, but I couldn't find any, again, that had partial threads. So what I did find is this is a reduced head socket head cap screw. So it has more of a normal height head similar to a bolt. It doesn't have the really extended head like a socket head cap screw does, but it still has a socket head end on it. Now these bolts I was able to get in 25 millimeters, 30 millimeters, 35 millimeters. So again, that's the only frustration with trying to do this with a shank, is that you can't get the exact length. So you try and get close. The measurements are a little bit weird too, because all the measurements on the site are minimum thread length, but it doesn't tell you how long the shank is. So you kind of have to guess and hope that you don't go too far one way or the other and get a bolt that's too short or doesn't have enough shank on it, or one that's got too long and you have to start stacking up washers. So I ended up doing pretty well with this one. These shanks on most of these bolts ended up maybe a millimeter too short. In other words, where the shank goes through here, it goes through the bearing, it comes out the other side and starts to go into the other side, but then it tapers off, and then the bolt is there. But my only alternative would have been to get one that was 5 millimeters longer, which means it would have had 5 more millimeters of shank. So I probably would have had 4 millimeters of shank sticking out the other side, where I would have had to stack up washers, and I certainly didn't want to do that. What I will say is these bolts fit really, really nice. The shank on here is like exact. In fact, I can't see a visual radius underneath this head, but I know that when I stuck it into my holes that I had drilled and reamed into these parts, that the head actually stuck up a little bit, and I did have to use a tapered end to actually put a little radius on the inside of my aluminum parts so that the head would sit all the way flat. So these did work really well. I do really like these bolts, so I would highly recommend them. Now, the ones that I bought actually require a special tool, and I shouldn't say it's a special tool. It's still an Allen head, but it's an Allen head that actually has an end on it. It's got a little post that sticks into the head way down at the bottom. I don't know if you can see this in the video here. It's kind of hard to see, but it's not required to use this tool. You can use a regular Allen wrench on these, but this supports it better when you're torquing and installing bolts. So yeah, Very happy with these. I'm actually using these on all of anything in the airplane that's using a bearing. I'm using these, and I think these will work really well. These are 8.8 was the highest grade, which I think is 110 to 120,000 psi, which meets the plan requirements. Fairly close. I did get some bolts also for the horizontal stabilizer, which are 6 millimeter, and I did get those in a grade 10. So anything less than 6 millimeters, I couldn't get anything bigger, in a higher strength than an 8.8. So these seem to work really well. So I'm very happy. You can see I've got these installed here, and you can see the nuts. Hopefully you can see that. You can see the washer that I put there, and I did a jet nut on the other side. Again, we don't want these very long because we don't want them to hit things. But yeah, again, like I said, I'm happy with these. I'm glad I got bolts with a shank on them. I was originally thinking I was just going to do a completely threaded bolt, but again, it's always better to have a shank on there. And like I said, these fit really tight, so it was very nice fit. So I'm very happy with how all this came out. It's super smooth. I don't have any play in anything. I can't wiggle anything. Everything is just solid. So for now, I'm going to say basically that the aileron and flaperons are done now until we build the wings. So I'm going to keep moving on and finish some of the other controls. You can see I still have the elevator controls I need to install, and I still have rudder pedals to finish over there. So that's what I'll start working on next.